Advanced glycation end products, or AGEs, result from a chain of chemical reactions which leads to the irreversible alteration of both matrix proteins through the mechanism of non-enzymatic glycation and oxidation. AGEs are believed to play a causative role in aging and age-related chronic diseases. The accumulation of AGEs in long-lived tissues can lead to vascular disease, cardiopathy, neuropathy, nephropathy, retinopathy and cataract, arthrosis. AGEs are formed through two distinctive pathways. One is the classic pathway of glycation or Maillard reaction, and the other is the newly identified oxidative pathway. The glycation mechanism typically occurs when there is an elevated sugar level. The increase of glucose inside the body will result in a non-enzymatic chemical reaction between sugar and proteins. In the beginning, this is a reversible process, and several intermediate products could be formed within hours, days, or even weeks. However, in the end, when the advanced glycation end products have been formed for several weeks, this process becomes irreversible. The newly formed AGEs can further cross-link with proteins and will remain in the tissues for years. The pathway occurs in the presence of oxidative stress or excessive reactive oxygen species. These highly reactive oxygen species can quickly become reactive dicarbonyl components, which will react rapidly with proteins, lipids, and DNA to form AGEs within an hour. AGEs affect nearly every type of cell and molecule in the body and can cause long-term damage to the tissues due to their irreversible formation and extremely long half-lives. The excess accumulation of AGEs will lead to faster aging and may accelerate the onset of many age-related diseases such as diabetes, renal failure, atherosclerosis, and Alzheimer's disease. In particular, AGEs play a pivotal role in the cardiovascular complications of diabetes and renal failure. In diabetic patients, the rise in sugar level will generally lead to an abnormal accumulation of AGEs. The excess of AGEs will accelerate the development of cardiovascular complications through the initiation of a wide range of abnormal responses in cells and tissues, such as inappropriate expression of growth factors, alteration of growth dynamics, accumulation of extracellular matrices, promotion of vasoregulatory dysfunction, and initiation of death pathways. In renal failure patients, chronic inflammation will create high levels of oxidative stress, which will lead to rapid AGE formation. Meanwhile, the ability to eliminate degraded AGEs is compromised due to kidney failure. As a result, patients are at risk for the consequential onset of cardiovascular comorbidity and mortality. The AGE reader is a proprietary medical device which can non-invasively assess the tissue accumulation of AGEs within 30 seconds. The result of its measurement enables an immediate risk prediction for cardiovascular risks in real time. Since AGEs lead to malfunctioning proteins, several of them have characteristic autofluorescence properties. Once they are excited by UV light, they will emit fluorescence in particular wavelengths. Powered with a proprietary technology, the AGE reader features a UV light source. Once it is turned on, the UV light will penetrate the dermal layer to a depth of about 1 millimeter, and this will trigger the AGEs under the skin to emit autofluorescence. The emitted autofluorescence is detected by the AGE reader, and the intensity of the fluorescence in particular wavelengths of AGEs will correlate to the quantity of AGEs in the tissue. In a normal person, this fluorescence is moderate, while in diabetic patients, for example, the high AGE level will result in higher fluorescence, which leads to the conclusion of increased cardiovascular risk.